All right, I'll go ahead and get started. Hello, everyone. This is Test 1 review for 3146, and this should cover all the sections, all the professors. They all teach the same stuff, thankfully. If you have any questions along the way, feel free to unmute yourself and ask, or ask in the chat box, and one of us will answer. So we will be going over computer organization, command line, operating system basics, C++ structs and pointers, processes, concepts, and implementation in C, and questions at the end. We'll start off with computer organization and the memory. So main memory is a collection of supercells. This is usually the RAM, and it is comprised of 1-bit cells. Next, we have the cache. This is closer to the processor so that the processor can access it quickly. And then we have memory at the lowest level, which is the registers, which will be inside the processor. Yes, at the end of the presentation, I will be emailing a recording to the professor and the slides, and then they will send that out to all of you. Within the register, we have the program counter and the stack pointer. And the memory at the lowest level allows us to access all these variables very quickly and reliably. Next, we have input-output. So most programs need some kind of input to do what you want them to do. The processor has multiple ways of handling this input. One is polling. This is extremely slow because this is the processor repeatedly asking, do you have new information for me, over and over again, which is inefficient and generally very slow. Another method for this input-output to happen is for something to interrupt the processor. So let's say we have a printer. Rather than the processor continuously asking the printer or scanner, hey, do you have a document for me? The printer or scanner can tell the processor, I have something for you. And then the processor will stop and then handle that. Next, we have command line file management. So for this, we use Bash, and a lot of companies will also use Bash. Bash allows you to execute commands directly to the computer. So in this case, I'm sure a lot of you use Linux to do this. You'll be using commands like cd, which will change directly, ls, and with ls in particular, you can feed ls parameters to get more information about what is in this directory, and then make directory, which will make a new directory wherever you want it to be, which will also take in a name. The C++ compiler. Just like Java, we need to compile the code before we can send it to the CPU to run. We use G++ to do this for this class. So with G++, you give a file name, and then the O parameter, and then the name of the executable you wanted to output. And then just to execute that program, all you have to do is dot slash and then the name of the executable, and that will execute that. Using the file management commands with this, we can do a lot. All right, and I'll pass it off to Dagan.
All right. So now into operating system basics. by definition, an operating system is something that sits between hardware and software. It helps the computer communicate with the user and vice versa. This is half of what this course is, operating systems and networking. And it gives us access to the hardware components through software. So we can manage program execution, memory, files, inputs and outputs, and pretty much everything. So operating system design separates the how from the what, which, and when. So the how being mechanism, and the what and which and when being policy. So there's two different types of system operation modes. There's the user, which executes programs on behalf of the user in a protected mode, which prevents any code from being executed that might destroy the computer or delete system 32 or whatever. And it has no direct access to hardware with restricted access to instructions and memory areas. So that just means that you're not allowed into places that are super important in the user mode. Now, the kernel mode is the exact opposite. You can do everything in a kernel mode. It executes on behalf of the operating system in a privileged mode, and it allows us to have complete access to all the areas of the hardware, memory, and instruction sets. So if we were in kernel mode, if we had kernel privileges, we could just go ahead and delete the entire operating system, which is not good, but that's what kernel privileges allow. So some more basics here. Some programs need to have access to the things that are in the kernel mode, but don't exactly have that form of access. So this is done through a system call, which interfaces a running program with the operating system and gives it a very controlled, specialized entry into the kernel mode that only grants it enough privileges to do what it needs to. And it gives the program certain parameters and boundaries, and causes the system to switch to kernel mode to do what it needs to do, and then immediately return to user mode. So there's actually several ways to construct an operating system. There's a monolithic operating system where the entire OS is in a single program, and all programs are operating in the kernel mode. Suffice to say, this can get kind of messy. Any part can bring any other part down, and it's a huge security risk in a lot of cases. Then there's a layered operating system where each part of the operating system gets layers that are independent of one another. Very popular architecture for operating systems. Then you have the microkernel, splits all of the functionality into smaller modules. A core is known as a microkernel and runs in kernel mode, and all other modules will interface with the microkernel for kernel mode. Modern operating systems use a mix of all of these approaches in what's called a hybrid approach. So a little bit of everything. Here's some diagrams for operating system models. And now into some C++ basics. We're going to quickly go through pointers and explain what's going on with all that. So we use a pointer if we need to access the direct memory location of a variable. So not the content of the variable, but where that variable is in memory. So we use a pointer to do that. So you can see here in this code example, we create an integer called test. We set that equal to 5. And then we create test pointer, an integer called test pointer. We're using that star operator on the left side there to declare that this is a pointer. And then we assign it to the ampersand test. And what that ampersand does is refers to that variable test by its address. So we're placing that address into our pointer that we just created. And then this print statement prints out test pointer, but you'll notice it also has that star operator there. which will print out 5. It'll dereference it from that memory location. So if you were to not have that star there, it would just print out some random memory address. And usually that's not what we want. But yeah, so to declare a pointer variable, you just use that star operator on the left-hand side of your declaration there, just like in that example. Yeah. So moving on into structs. A struct is very similar to a class, but it's a lot more lightweight. It's usually used for storing information. With a struct, you're able to store multiple fields together, which is a very helpful thing to have. And to access the members of the struct, so to declare a struct, you define a struct and then put in all of the members or variables inside of that struct. And then to actually access those, you can use the dot operator or the pointer operator. And then just like an integer or any other variable, we can actually create a pointer to a struct. If we're trying to dereference something from that struct pointer, we would use the arrow operator.
All right. So processes. Processes are an abstraction of a running instance of the program. And let's see. Oops, sorry. So yeah, we have they're created from cloning. And as you can see, there is the process cycle, right? When a new process is created, it goes from the new stage to the ready stage, and then it will be scheduled by the operating system, and it'll move to the running stage. Now, it can either complete its process and go to the terminated stage, or two things might happen. One is that it gets interrupted from like an IO event, and it would go to the waiting stage. And then once that event is done, it can go back to the ready stage and then start over its running and terminated thing. Or if the operating system switches processes, that's when the preemption comes in. Instead of going to the waiting state, it'll actually go back to the ready state and then go on when it gets called up again. Now, the process control block, it's simply a data structure that just keeps track of various information about a process. As you can see, it contains the process ID, the process state, program counter, registers, and all these other information. Now to the really important stuff, creating a process. So in Unix-based processes, so Linux, even Mac OS, processes are cloned from an existing process. And when we're doing C++, we use a fork statement to do that. So, and when you call a fork statement, it returns different values depending on the process. If it returns a -1, that means there was an error creating a process. If it's a 0, that means your process is child. And if it returns a 1, it is a parent. So the next thing is the exec vp command. The exec vp command can be used to change a process's memory image. So in one of our previous assignments, we had to use it, and we had to pass in those parameters, right? We had an array called args, which was passed in for both, right? We passed in the first element, arg0, and just the whole array, args, right? So we could execute certain commands. So what it is a copy on write, or it starts with shared memory, and it only makes a copy when the data is modified. And with processes, right, when you create a clone, it's called a child. So you can refer to childs to certain things when certain things happen to it because of the OS having a hierarchy. If a parent terminates before the child, the child will become an orphan and it becomes adopted by the init process. But if the child is terminated before the parent, the child becomes a zombie and then can be reaped by its parent. And for that to happen, the OS, it'll provide a wait command for that to happen. So we have some steps that normally happens with processes. So a save program, it counters and some of the registers on the stack. Sorry, counts and registers on stack. It'll load a program counter specified in the interrupt vector. And the interrupt vector is just, it has the address of like interrupt service routine. So something that will just interrupt whatever's going on. And then you also have the ASM that saves context info, so registers, etc., in the program process control block of the current process. Then you also have just setting up a new stack. Then you have the remaining work for the specific interrupt type, and then you have choose new process. Choosing the OS chooses a new process to be scheduled, and then you have it restoring context info for a new process and starts it. Um, so that's more of like a super in-depth thing of our little cycle that we have from ready to waiting to terminated, or from uh, ready to go back. Sorry, not ready, running to go back from preemption or because of some other interrupt. It's just more in-depth. So next would be the code review. So these are just a couple of questions. We'll give you, I don't know, how long should we give for them to, are there answers or answer choices on these ones, or? Okay, no, it's just code review. Okay. So Chris, how much time do you want to give them just to put in some answers uh, before we go through it? Do you want to give them like 30 seconds or so, or maybe longer?
Maybe a minute or two.
Okay, minute or two. That works. So everyone take a look at this little snippet of code right here. We have a float being created, a double, and then another integer called result. And then, so just go ahead and take some time and just type out into the chat, or yeah, just type out into the chat for now. Whatever your answer would be. We'll give you about a minute.
Yep, I see most of you are saying two.
Yeah. So yeah, the correct answer. Oh,
Nope. Okay, that's not the answer.
yeah, it's yeah. We just had to talk about them. Yeah. So yeah, the answer would be two here. Does anyone want to give what their reasoning was for either putting two or some other answer? Love to hear what you guys think. And you can speak in this one if you want. If you don't want to type.
I can go. Someone else.
Okay.
It's because even though num1 and num2 are doubles and floats, they're being stored in result when they're being multiplied. And result is an integer, so it floors it. Even though it's 2.9, it'll floor it down to the nearest int.
Yeah.
Or not nearest, but the bottom int, for sure.
Right. It wouldn't be flooring though. It'd be truncating. Floor would be if it's less than like 0.5, right? But truncating just removes
Right.
the little decimal part.
Right.
So Josh, yes, you were right there. It does truncate it. That's why it's written as 2 and not 2.0 or 2.9 or any other value. Actually, before we move on, did anyone have any questions on that one? What's the difference between a float and double? It's mainly the just how much memory and how accurate it is. So correct me if I'm wrong, Chris, but I believe that the double has the greatest amount of memory and accuracy compared to a float.
Yes, that's correct.
Okay. Yeah, so that's mainly your biggest difference.
It's just how many, I guess, bits you're giving the variable.
Anyone else have any other questions? Okay, I think we're good to move on to the next one then. Oh, float memory is greater. So it should be the other way around. Double has more memory than a float. Yeah, I believe you're correct, Josh. That the double has 32, while float has 16.
All right, I'll go ahead and move on to the next one.
Jacob, so for even if it was a double or a float, it wouldn't matter because you only have that single decimal point, 0.9. The double really comes into account when you have a lot of decimal places. So not just like one or two. Say if you needed like hundreds or maybe even a couple hundred, almost 1,000 decimal places, that's when that memory for a double and float comes into play. So for most things you're doing in classes, it wouldn't really impact that. Mhm. Okay, so we have a little code snippet, int var equals 5, then you're creating a pointer called p, an integer pointer called p. You give it the value of var using the address of operator. And there's two ways you can do it. You can either do it split up like that, or on the right hand side, you can just shove it into one little statement. And so below that's a little diagram of how that's working. So your pointer p without using a dereference operator. Remember, the dereference operator is your asterisk. Your address of operator is your ampersand. So if you just used p, it should just give you the memory address. So in this case, we have 0x fa blah 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 0 at the end. But then if you use the dereference operator, the asterisk, then you get the value that the pointer is pointing to, which in this case is var, and var has a value of 5. So then we have our little questions over there. We have 5 different print statements. If you guys could just quickly type in what would be the thing that or what would be the value that gets printed out. And we'll give you a bit, probably say in a minute or so. Okay, and cut it off right there. So let's see, what are our answers like? Okay, looks like everyone pretty much agrees on what's going on. So correct, your first thing, print var, that just prints out 5 because that's just what the value inside var is. And then printing out ampersand, which is the address of operator, var would give out your memory address. And printing out p would also achieve the same thing. Printing out uh, the asterisk, which is your dereference operator, p would again give you 5 because that's where p is pointing to. And let's see, what is everyone saying for printing address of p? So we got memory address, an error, memory address, error, or new memory address, memory address. Okay. So I see there's some contention between us. So if you actually go ahead and try it in your own machines, you shouldn't really actually get an error because most IDEs would just understand and usually just ignore the little ampersand in front of it and would just print out the memory address. So you should just get the regular value of p instead of any error or anything occurring. Would it not print out the memory address of p itself? So p, you can't really get the memory address of p itself because p is just the memory address of another value. That's really all a pointer is. So you can't really get a memory address of a memory address, if that makes sense. It's not like Inception or anything. So it does not take a space in memory. Actually, that is a good question. Does it take up a space in memory? It should. Now that I think about it, it should.
I think it does, but I don't think that's something that's going to be on the test.
Yeah. So I would just, for the takeaway for the test would be just don't do it. I think it would require. Yeah, so I think what Dagan typed in the chat would probably be it. It would require ampersand p to be stored in a double pointer, so it'd be something like int asterisk asterisk p equals ampersand p. So definitely not something you need to know for the test. I really the main takeaway would just be don't do number 5. Just don't use ampersand and a pointer. Use the other 4 variations. Yep. Anyone else on questions on? Those are good questions, by the way. So okay, I think we're good to go to the next one then. All right, so something that should look pretty familiar to you guys. Get a integer called myint, set equal to 15, create a variable called myPointer, set it to the memory address of myint, and then we have 4 printout statements. If you guys could just take a minute and type out what do you think would be printed out for each of those printout statements.
Although the comments kind of give it away. Now here's a double question. Are the two memory addresses the same?
Ooh. So Chris asked, would the memory addresses, would they both be the same memory address or would they be different? So those first two printout statements.
And good, I see all of you are saying yes. That's correct.
Yep. Okay. Oh, they'd be the same.
Andrew, you're not sure if they would be the same? Yeah, so this first printout statement is just printing the pointer, and the pointer is just pointing to my int. So they are both pointing, or they both have the same memory address.
Awesome. And it looks like everyone else is understood what's going on. So yeah, you got your memory address for my pointer, then a memory address because you use the address of operator for my int. Then you get the value pointed to my pointer, which is 15, and the value of my int, which is also 15. Anyone have any questions on this one? Should be pretty fresh in your minds from, I believe it was Pointer Basics. That was the coding assignment you guys had on that one.
I see there's no. Oh,
Oh. Does exec VP change memory address? So exec VP. Oh, will we have to code on the tester? Just look at code. So there will be a couple coding questions, more of. Well, actually, I can't really give you an exact thing, but yeah, there will be a couple coding questions. And then, so Walter, does exec VP change the memory address? So it doesn't change the memory address. It changes what was it called? Chris, do you remember what it was called again? It just changes the process, right? The memory image. Memory image. That's what it is. Yeah.
all right. I think I can move on to the next question.
All right. All right. So structs and functions. So let's see. So we have our structure called point, and it has two floats in it. We got an x and a y. We have our display array function that has a for loop, and it prints out two things: my point, an array, and the members, or an array of structures, and the members of that structures is what it prints out. And then inside of main, you have your structure array called point list, and it has two elements that each have two different values. And now we have our display array point, display. We call our display array function, and we pass in point list. So I don't really see if there's a question in there. Really, it's more of okay. So yeah, that's just basically a run over of structures. Do you guys have any specific questions about structures? Like how they work, how you access them? How is a struct different than a method? So a structure isn't a method, it's more of a user created data type, really. Because you create it, call it something, and then you can give it certain attributes or fields. So in this case, point has an x value and a y value. So Walter says x equals first array, y equals second array. So the yeah. So like Dagan said, the x and y are the fields for the point structure. So if you look at the declaration of the point structure, you have a float x and a float y. So in our point list, 1.0 would be the x and 2.5 would be the y for the first point. 3.2 would be the x and 5.4 would be the y for the second points. And then why would you use a struct rather than just declaring the variables outside / inside main? So a structure just provides an easy and convenient way to get a variable that has multiple fields. So with the point, right, you can have a variable that has an x and a y. And if you didn't have it, it's kind of messy to go like a roundabout way to kind of make it. So it just simplifies a process into having just one data type that you can just create and pull from. You don't have to create like a new instance or anything, or sorry, not a new instance. You don't have to like. Uh, okay. Hopefully that was just enough. If not, I can try and better explain it.
An example would be like you could make a person structure, and then you can give that person structure a name, an age, a list of hobbies, and then that person structure is just a variable you can use throughout the program.
Yeah, exactly. Thank you, Chris. So you use it.
I have a question as well.
Yeah, go ahead.
Does so the way the order in which they're presented in the array is the order in which they're declared, or the order in which they're declared is how they're entered into the array?
Are you talking about like the float x and float y, right?
Yeah.
Yeah,
So for the first one, it's
that's right.
1.0, 2.5. That's x, y, right?
Yes, exactly.
So if you had a z, it would be 1.0, 2.5, and then z.
Whatever. Right? Exactly. Yes.
Okay.
And Josh, yes, you'd use a struct for the same reason you use a class. Correct.
And can a struct be different data types?
So structs in themselves are different data types because.
No, I mean like, can they hold different data types?
Yes, they can. Okay. They don't just have to have floats. You can have one with a float, a string, character array.
So they can hold a string and a double and an integer all at the same time.
Yes. If you remember from that patient structure you made, you had your name, which was a string, or sorry, not a string, a character array, an age, which was an int, and a balance, which was a double. So yeah, no problem holding different data types. Any other questions on structures? How they're used in functions or anything? Do you guys remember the different operators to access members of a struct, depending if it's like a normal data type or a pointer? Because there is a difference. Nope. Okay, so with a regular, yeah, exactly. Yep, you use a period for a normal data type, and a pointer you actually have two different ways. You could either wrap it in parentheses and dereference it, and then just use the period, or you can use the little arrow that's in the chat. You can use that as well without dereferencing it.
Why aren't you using a period in this code?
Why are we not using a? Sorry, what?
A period in
We
this
are
code?
right here.
Oh, we are. We're using a period.
The red boxes.
Mm-hmm. The my points brackets
okay.
I dot x, my points brackets I dot y. How do I use the other way? So the other way is just dereferencing it. So with if you had you just use the parentheses, right, and dereference the thing, and then dot x dot y. Yeah. Mm-hmm. Yeah. Any other questions on structs, functions that structs you or that have structs in them? So like you would use the arrow when you want to like print the actual value instead of the address. No, so they're both just ways of accessing members of a struct. It's not that it accesses the actual value or the address. They're just to access the actual values themselves. Yep, they're interchangeable. Exactly, just like Dayton said. The dereferencing .x is the same as using the little arrow x. Good questions. Good questions. Anything else on structures?
All right, I'll go ahead and move on to Forky.
Sounds good. All right, forks. So in our main method, we got a for loop, and inside that for loop, we have a fork and a print statement that's printing out hi. So we got two questions here. Where is the first process created? And two, how many times, if any, will hi be printed to the console?
One thing I can recommend for questions like this is having a sheet of paper ready and writing out each step of the for loop. I'll give you guys a few more seconds to answer the question. All right, so that is correct. Number one is the within the main, and then 6 times is the correct answer.
Yep. Okay. So got some people that got 6. See, anyone want to tell us their thought process on how they arrived at their answer? Okay. So in case someone's typing, I'll just go ahead and talk at least about the first
I
question.
can go
Oh.
if you want.
Okay, yeah. Awesome. Go ahead.
For the first one or for the second one?
Let's go with the first one.
I just thought that that's the beginning of the program. And the beginning of the program has to have a set of instructions, something to follow through with it. So that would be the main process.
Yep, you're exactly right. Yeah, so the first process it's created when you start executing the program, so it's in the main. Do you want to go ahead and give us your reasoning for the second one as well, or
Yeah, I can.
awesome?
So when the first one, when the main process goes through the for loop when I equals 0, it forks and it creates a child process. And that child process will execute the print statement and it'll print out high, while the main process will also print out high. So that's already 2. And then I iterates to 1, and you have the main process, which will then again fork and create another a third process, and you have the child process from the previous iteration that will also fork and create another process, and all 4 of those processes will print out high. So that's
Excellent.
6 times.
Yep. Awesome job.
process.
Yeah, so what he said was right. So P1 enters that for loop, creates that first copy of itself, P2, goes and prints high. P2 that was just created prints high as well. Then they're both in that for loop, and the for loop increments to the next loop. So now I is equal to 1. P1 hits that fork statement again, makes P3. P1 then goes ahead and finishes up, prints high, and it's done. P2, it hits that fork loop or fork statement as well, so it makes another process, P4, and then also goes to that print statement. P3 and P4, they were created at that fork, right? So they don't fork themselves, they just go down to the print statement and print out high themselves. So in total, 6. Does anyone have any questions on that one? It doesn't have to be about this specific, it could be forks. Anything about forks? So if there is a question about where the second process is created, what would that be? So the second process is created after the main process P1 first runs into the fork statement. So if the for loop was line 1, fork was line 2, and print high was line 3, the second process is created at line 2, the fork. Yep, no problem. Anyone else got any questions on forks? So so P1 and P2 are parents. So P2 is both a parent and a child, but P1 is just a parent. How many processes would we have like if it was I is less than 3? So if I was less than 3, you'd have P1, P2, P3, and P4 each creating a process. So we'd have 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2. So it should be 8, right, Chris? 2 to the third?
Yes.
Yes. So it'd be 2 to the third, which would be 8 processes. Good questions. Anyone else got any questions on forks? All right then. All right, so let's just open up the floor to questions on any of the subjects we just went over. Any questions that you guys have for us? Not just forks, but any of the things we went over.
Is this like the questions part?
Yeah. It should be the next slide, Chris.
Yeah, it won't let me.
Okay. Well, the next slide is just any final questions. So, any questions, guys?
Do you guys have any tips for studying? Like, what did you guys do to succeed?
Sorry, Walter. Could you say that again? You had some background noise going on, kind of muffled you up. Tips for studying. What did you guys do to succeed? Okay, so your teacher should have posted a study guide. That's very helpful. And yeah, I see you guys with the XF VP. We'll go over that soon. So yeah, so the study guide's really helpful. Um, if I need more help, are you guys TAs or tutoring center? So I'm a TA for Professor Brahma Prasad, and both Dagan and Chris are tutors for at the tutoring center. But for the studying, definitely the study guide's really important, as well as just watching the content videos that your teachers might have posted. I know Professor Ramar Prasad posted those videos, so you guys take notes of those, of any important things. So the the cycle of a process or so and so. Just really staying on top of those things, right? And of course, coming to us if you need help. Like if you have a question but you don't get it answered, that's something that could have been on the test, right? You never know. So really just reaching out if you need help and then using all your resources available to you. Okay. And then exec VP. Trouble. Okay. Chris, do you want to go ahead over exec VP?
Sure. Let me see what the question.
We had two of them. So one of them was they have trouble understanding what the point of exec VP is, and then just straightforward, can you go over exec VP?
Sure. So exec VP just allows you to change what the current process is executing. So let's say our current process is running like one variation of the list command. We can use exec VP to run a new command line argument through exec VP. And that doesn't just extend to like bash commands, but you could have it change what program the current process is executing. And you do that with just the arguments you want to feed the program or feed the current process, and then the arguments array. Now, I don't think you'll touch on what's happening behind the scenes with exec VP and the args. Do you, Hemeth?
Not really. If there is a question on exec VP, it's most likely just like what the parameters are, really.
Yeah, you just have to know what information to give it.
Yeah.
It handles a lot of stuff for you.
And just like a general overview of what it's doing. So changing your processes, memory image. That's pretty much all you need to know about it. Yeah, Sweat. Do you got a question?
Yeah, so I just wanted to ask, like, as the lockdown browser test a quiz, we were able to access the lecture slides. So would that be the same thing for the original test? Like, would we be able to access the lecture slides?
Let's see. I don't remember if the actual lecture slides are accessible. I know that your My Files folder is accessible. Um, I'll check with the professor and let you guys know if you can access just the regular lecture slides without. But I'm pretty sure you can. But
Yeah,
I'll
because
confirm it.
it shows a like it shows a tab inside the like test lockdown browser quiz. That's the only reason I asked.
Okay, I got you. Yeah, so they should be available, but I will again check to make sure that you guys have access to it.
Okay, yeah,
Hmm.
thank
The
you.
first question, it changes the copy process. In this example, yes, it's changing what the child process is executing. So if ID is equal to 0, that is the child, and we are changing what the child is doing, and the parent will continue on doing whatever it was doing. But
And
it
Jacob,
doesn't have to be a child process. You could run this on your main process.
correct. And Jacob had a question. What are pointers and the address off operator actually for? It kind of just seems like coding exercises. Not sure how they are applicable or valuable, though. That is a good question. So let's see. Dagan, do you want to go over it? You haven't been.
Yeah, sure.
Yeah? All right.
I mean, essentially, yeah, as you were saying, kind of the stuff we were going over initially to kind of give examples to you guys of how to use the syntax and everything, that is a little bit trivial. But really, the short answer here is just to use pointers when you can't use anything else. I mean, there's just a really large breadth of potential situations where you would have to use a pointer, and then others where maybe you wouldn't. But yeah, it's essentially just when you really absolutely have to. You can also do some special things with a pointer, but yeah, that's really all I have on that.
Yeah, so like Dagan said, it's really for when you have to, when there's no other really way for you to just use a regular data type. Um, they do get you a little bit more comfortable with the whole memory addresses and what's going on really in the background, which you kind of do need this for operating systems themselves. You need to have a little bit more knowledge about what's really going on in the background, how certain variables that you create take up this section of memory, and how you can access that memory and change that as well.
And yeah, additionally, you're going to find yourself using them the most with more complex data types. Whether that be custom defined structs that you create or arrays, classes, types, that kind of stuff. So later on down the line, I'm sure you'll find many different applications. But as for like the scope of this course, I don't think y'all go too much into it.
They do touch on queue sort, which requires you to cast them to void pointers and then back to whatever data type they were before.
Yeah. Let's see. So Walter, yeah, we can definitely hold more review sessions. It's really all up to you guys, right? It's all up to the demand. If you guys aren't showing up, then that just it tells us that okay, maybe it's not necessary for us to host them. But since we had a pretty good turnout, I think we'll probably have more of these, right, Chris?
Yeah, we'll probably have one for every test.
Mm-hmm. And so Jacob, so most of the information conceptually, yes, will come off the slides and the videos. Some of the things that were done in the uh, program assignments, like how you used execvp or how you created a struct or access members of a struct, those those like certain things you definitely need to remember, even if they weren't necessarily um, inside of the slides. You will need some stuff from those exercises and assignments you've done, but mainly all the theoretical knowledge will come from the slides and videos. Awesome. So is this technically open book if you submit the files to the My File folder? Yes. Um, I would not suggest only relying on your access to the uh, slides, because you don't have like a search function. You don't have Control F to just search through the slides or anything. So you wouldn't really have enough time if you just manually scroll through all the slides. So it's there if there's like that certain specific thing you just forgot, but you would still really need to study on your own as well. Any other questions, guys? Yeah, no problem, Jacob.
All right, so it looks like we can go ahead and wrap it up. Thanks everyone for coming out. It's good to have good turnout for things like this, so we know to do more of it in the future.
Definitely.
Yep. Thanks, everyone.
And good luck on your tests.